In today's session, the topic is data mining and machine learning tools for reference tagging, filtering and stopping screening early. And we have Lena Schmidt, who is presenting today. Lena, could I ask, are you happy for people to, do you want to kind of give the presentation and take all of the questions at the end? Or are you happy for people to kind of ask questions as we go through? I can keep an eye on sort of people who've got their, maybe people put their hands up or put a question in the chat. What would you prefer, Lena?
So I think because we're going through a couple of like different topics and a couple of different things, it would probably make sense if you just ask the questions as they come along. And yeah, if I don't notice it because I have my screen shared or something, then please do unmute yourself or yeah, just let me know. That would be great.
Brilliant, that's great. Well, in that case, please feel free to unmute yourselves. And if you don't feel comfortable doing that, please pop a question in the chat and then I can ask Lena on your behalf. So on that note, I will hand over to Lena.
Yes, thank you very much. So I think the first thing I'm going to try is I'm going to try and share my whole screen. And please, if anyone could let me know. Can you see the PowerPoint presentation?
Yes.
Okay, and now because my screen is on the other side, I'm going to stop my video. Also, I think just to make sure that my bandwidth is good enough to actually like, you know, that let me know, by the way, if for some reason I'm going to be breaking up or if the voice quality goes down. But yeah, so let's go into the PowerPoint presentation. Oh, my computer is a little bit sluggish. Yes, so yeah, definitely. Thank you for joining the meeting today. So my topic today is I'm going to be talking about some text mining and machine learning approaches in systematic review, but also I think mostly like evidence mapping and rapid review tools. So my name is Lena. I have previously worked, or actually am still as part-time working at Siom, which is a company that does systematic review software. But I've also recently started as a PhD student at Nerio. So let me go to our next slide. So basically, I think I'm just broadly going to talk about like 3 different systematic review tools, but also later on, I'm going to actually talk about some like real world projects that we've done, like some evidence mapping projects around COVID and to some, like experiences of how we've actually like used automation during some like review and evidence mapping projects. So I guess the 3 tools that I'm going to be mostly talking about, though, is Active Screener, which you can see here in the middle. It's actually a literature screening application. It's like a web app for all kinds of literature reviews or like rapid reviews or evidence maps. You can do like dual screening, full text screening, conflict resolution. So it has actually a couple of features that I think are important for different kinds of review projects. And it also does like inter-rater reliability, kappa scores and things like that, and PDF upload in batches if you have your PDFs in like an EndNote library format. And then on the left, that's the second tool I'll be talking about, a Swift review, which actually I've already heard from a couple of colleagues at Nerio that they've used it or that they've sort of looked into using it. So that one is like it's a completely free desktop application for text mining and data visualization, but it's kind of like focused on health related data and toxicology data. So can like do Boolean searches, adjacency searches with it to like filter data sets and like also use it to actually share projects. And then on the right side, that's Fiddle. It's a tool that's actually currently in using and testing stage, but it's for PDF text extraction and data mining for like full texts for like PICOs, toxicology and animal data. And it actually includes lots of data mining models that have been also published in the literature. So it will include like, for example, the models that are in Robot Reviewer. And to just sort of as a broad overview, so none of these tools really supports the whole systematic review process right now, but they do actually support like different parts of it, and trying, you know, depending on like which review methodology and how sort of rigorous your review methodology is, you can like use different parts of you know, like text mining and automation within the tools to actually hope to like speed up the process. So yeah, active screener, you can like see a sort of screenshot there on the right, but I'm also going to try later if I don't get any technical problems to actually go and share the you know, like a little live demo of it. But yes, web-based, and it supports different review times. So most people, at least like in the US, because Siom is a US-based company, use it for like short turnaround projects, so projects that they really want to complete quite fastly, but it also like supports full dual screening and conflict resolution, like question-based level. And keyword highlighting. So as you can see here in the middle of the picture, somebody, for example, they didn't want, so they have like a negative highlighting for DNA because that's not relevant to their review, but then a PAH, which is polycyclic, this is some group of chemical, let's say it like that, PAH is a group of chemical, and they have basically highlighted that as being relevant. And then on the right side, you can like do like little data extraction forms, etc., that you can fill out like during the screening. But I think like really the most effort, or like that we've sort of put in with active screener, is that to like, you know, in training and evaluating like a reference prioritization system. So that's basically the AI part within the software, and that's quite common actually across many tools. So I mean, you've probably used like Epi Reviewer and an apps tracker, and they do have it. I'm not sure if Covidence have it, but it's like this sort of active learning of screening decisions and then reordering of your references. But the problem with this sometimes is that it is actually, you know, you can prioritize your references as much as you want, but if you are not really certain or confident of when you can stop screening, then you're not really saving any time with it. So you can see like normally when you screen your references and they're like randomly in your data set, you're sort of expecting to find them in a random manner. But if you're using some prioritization, and you can then basically you can find your relevant references faster. So we've actually done something similar for that in a project at Nerio as well, where we basically developed like a reference reordering system for some of the scan results that brings the relevant references to the front. But I think like the next step always in systematic review automation, or the automation of screening, is not only to give the relevant references faster, but also to tell the reviewer when you can stop screening. So with an active screener, the good thing is like that we had about 20 to 30 sort of finished systematic reviews as like a data set, and then using that data set actually build a statistical model that can estimate the sensitivity of your screen reference batch. So it basically can reorder the references, but then it also tells you, okay, now it estimates that you found 95 or 95 of the included references, and that you can stop screening. So you can see the green line here actually is sort of what then shows that active screener now estimates that 95% of the relevant references have been found. And this is different in every project. So this is one project, and then here you can see on this project it was slightly different because this was just an update of an existing project. So we already knew all the included references, and then that was like used to, like, for example, kickstart the model. And then you can see after screening, I don't know, maybe 100, maybe 250 references, actually all of the included references in the data set had been found. And at that stage, because screening maybe 1,000 more references, the the reviewers then said, hey, we've just screened 1,000 references. There was nothing relevant in there. And that's sort of the point where they said, okay, no, we've stopped screening. Similarly here on the left side, in that plot, that was a COVID related project with very early COVID data where the language within the references was really, really, you know, the reporting back then, like first or 2 months of the COVID pandemic, was not very well defined. So there we sort of decided to screen a little bit longer because there was so much variability in the natural language and the text. But then we again like just sort of decided to stop screening when like after 1,000 references, we didn't find like a relevant included reference in the screening. That's sort of the screening part of it. But then these are like actually fairly recent additions. So for example, in calculating, so there's like a conflict resolution interface right now, which you can see here on the bottom. So for example, every time here at the very bottom, you can see me and my colleague screened like a reference. He said included, I said excluded. So that's the way how it's like shown to you. And then when you click on resolve, you basically like get a pop-up to like resolve the conflict right there. And then also on this top, and I'm not sure if you can actually see my mouse, but like the top can you see my mouse? Sorry. Otherwise, I'm going to have to explain where I am right now.
Yes, sorry, Lena. I was just trying to find my unmute. Yes, I can see your mouse.
So you can see here on the bottom. This was the include exclude question, but then also there like the conflict resolution is also for you know, multiple choice or radio button questions as well. And then as you go through a project, really, you know, if you do double screening or like dual data extraction, sometimes, you know, you want to see like how are your conflicts between your screeners. So for this question here, for example, we have 5 users, user A, B, C, D, and E. And when you put your project on dual screening, sometimes, you know, user D and user A, for example, they would screen the same reference and they would have a conflict, or they wouldn't have a conflict. So what this table here shows is all the pairwise Cohen's kappa scores between all your reviewers for a specific data extraction or screening question. So that's quite cool if you want to see, okay, you know, do we want to do dual data extraction for all our data items? You can run it on dual and then see whether your screeners actually agree with each other or not. And then that you can actually also see it like now on a timeline view. So for example, for the exclusion region question, we had a project with 5 screeners, and this just shows like their kappa scores across the lifetime of the project. So you can see, for example, at the beginning, they might be slightly lower, but then as the screeners, like they calibrate themselves and they start actually making, you know, like the same decisions. And now just to actually show you, can you see my browser?
Yes, I can.
So this is just like a sort of real life project. I don't think I've actually shown this graph here. So I've shown this graph as a screenshot, but this is basically how it comes out on Active Screener. So this is actually for my PhD literature review that I've actually just stopped screening, really, because I've had 7,500 references. But then, you know, after like doing the reordering and stuff, after like screening 1,000 references and not finding any relevant references, and this is only like, you know, like a evidence map, so decided to sort of stop screening early. But this is how it really looks like. So because I've set 95% of sensitivity, it's now basically telling me that I can stop screening. And in screening itself, really, so I can say I want to screen a title and abstract, or I've also added like this full text level. So for my full text screening, I've just added like a couple of data extraction items to like a data extraction form here. So I've got like exclusion reasons as radio buttons, and then free texts are like checkboxes and things like that within it. So that is this, and I hope you can see my slides again.
Yes. Yes.
And unless anybody has any questions about that for now, I think I'd already sort of move on to like different kind of topic.
Lena.
Yeah.
Hello, sorry to interrupt. I was just wondering if you have any insight about that compared to the Rayan software that we sometimes use here, because that also does a reordering thing, I think, and I don't know if you've used that one as well and know anything about the differences.
So I've used Rayan, and I've also used the reordering, and actually to compare the two softwares, I would need to go and see the Rayan publication on how they've validated their model, because so the active screener itself was validated on, you know, like internal data sets that we had of finished reviews, but also based on one big publicly available data set. So I think it's Cohen or something. And I think almost all the screening softwares that you have would have, I think, used at least for training or evaluation this one data set. So I think this is if they have used this data set, then I think we could compare how well the tools work. But yeah, I think like the main difference between Rayan and Active Screener at this point is just that with Rayan, you don't really know when you can stop screening unless, like, you know, you're feeling yourself that you're not finding any new references. I think whereas Active Screener, like, you know, at least it kind of tries to visualize the process, so to try and, you know, estimate also, like, you know, how many references do you still have to find. So I think that's pretty much the only difference. But I think in performance, honestly, they should probably be roughly the same. But then the performance also depends on your kind of project that you're doing, and it's always going to like vary quite wildly depending on your reference data set that you have.
Great, thank you. That's really helpful.
Yeah. So thank you. So this next one is Fiddle. This is kind of like more on like what's sort of on the horizon and like full text data extraction and data mining. So it's not a published tool yet, but it's actually like in the phase, so doing some user testing on it with some research groups in the US. So basically Fiddle itself consists of an algorithm to extract text from PDFs. So not only the fully digitalized new texts, but also like older and bad quality PDFs. So, but then also in the background, we've integrated quite a few deep learning and text mining tools that were published in the literature and that actually were also developed in-house. So for example, all the robot reviewer, you know, like methods, I think you've probably heard about those at the robot reviewer. I have a couple of like deep learning text mining tools, but also have some newer models in there. And the models are basically mostly for evidence-based medicine, for toxicology and animal research. And the kind of new thing that it does, it is also from your full text, it also classifies the sections of your full text. So it would classify the methods or the abstracts or the results section, and then allow you to actually run like data mining models just on these specific text sections, just because you know, sometimes there's a lot of noise. Like if you're trying to mine PICOs and then you go into the introduction, you would have like mentions of different other interventions or different other population groups that essentially are not too you know, useful for your research. So be able to, like, once this is fully published, to actually be able to, you know, just mine text or tag, runs full text searches and tagging just on the specific parts of the documents. But yeah, so this is currently in user testing as well. So if anybody like has a large amount of like full text and want to do like full text search and tagging, you're more than welcome to actually maybe get in touch and test it, you know, at some stage, hopefully sort of within this year. But then, yeah, the next one is Swift review, and that's, I think, this is actually what I was thinking might hopefully be useful to some of the people at Newcastle University and in Nerio. And I've actually heard from, I think, Sonia the other day that they've actually already had a look at it. So it's a free desktop application to manage, tag, and visualize data for reviews and evidence maps. So you can see like a small screenshot here on the right side. And sort of initially, I think the idea behind it was that your normal systematic review searches are quite imprecise. So to have this high sensitivity, they just return way too many results. So you have like all these large workloads and large screening projects, and basically like sometimes like it's just hard to like keep an overview over a project when it's really large. So I think main thing is like when this was developed, like looking at, for example, toxicology research or something, like the toxicology research that I've seen, sometimes you have systematic searches about like different groups of chemicals that would return like 90,000 search results or something like that. But so basically that's why Swift Review is like a text mining workbench for systematic reviews, and to refine, filter, but also to apply tagging to a data set, to like group a data set into smaller different groups. So like we have this document tagging and browsing of tag references, and then heat maps, and you can do quite, like your searches within Swift Review, they can be really complex as well. So you can do Boolean searches, adjacency searches, etc. And these searches, if you put them here in the search interface, and I'm going to do a quick demo of that later as well, are automatically going to filter down your all your documents within Swift Review. And the moment you filter them down like that, you can tag them. So the search here, somebody searched on title and abstract for any kind of like, hypertension or blood pressure related information, which caused like some 30,000 documents to be filtered down to only 61. And then it kind of like shows where was my document tagged. And then if you're happy with that, you can basically just apply like a hypertension tag category or something within Swift Review. And then it's kind of interoperable with, I guess, as much software as possible. So definitely with Active Screener, but then also Hawk, which is an application used mostly by the US government for environmental reviews, but you can also like export data like tag groups and CSV or RIS files. And then like in general, like if you have like broad tagging categories or topic models or something like that, it can like do these heat maps and these word clouds and pie charts. And so what we've done in SciOM is we've used it for evidence mapping. So in early 2020, we did this thing where we used Active Screener and Swift Review together to do a rapid evidence map. And that's actually the practical example that I wanted to show to you today. So basically, let me go back to my screen. Can you see a different window now? Can you see Swift Review?
Yes, I can, Lena. I can see a nice orange and green pie chart.
Thank you. Yeah, so basically we've done this rapid evidence map, and we've also published it. That was already in November 2020. And what you can do with that is that there's actually a link on my slides. Is if you follow that link, you can download the Swift Review file for this project. So that's just like a zipped up file that you can use to load into Swift Review if you have Swift Review installed on your computer, and then you can basically just explore all the results from the evidence map as I'm going to show it to you. So basically for our rapid evidence map, oh maybe before I go here, sorry, maybe I should actually just quickly give the overview of the evidence map before that. Sorry, let me, sorry, can you see the previous slide?
Yeah, I can see the slide entitled Swift Review.
Yeah, okay, thank you. So basically the first thing is we identified like a scope of an evidence map. So in our case, that was what are the risk and protective factors associated with COVID-19? Because this was done actually in April 2020. So when we had about, you know, 2 or 3, like 2 months worth of COVID research, we wanted to know what are risk and protective factors. So we did we basically retrieved records, and then we established our study eligibility criteria for our screening process, the title and abstract screening. And then within Swift Review, and that's what I'm actually going to show you in the practical demo, we've actually, after we screened articles for inclusion, we've developed different tagging strategies to tag and categorize references into risk and protective factors, and then basically use Swift Review to apply and verify these tags and then create the evidence map. Yes, so now we're back to Swift Review. So basically what you see, this nice pie chart on the top right here, this is when we imported the references from Active Screener after screening. What had happened is we had included 217 references. So they are here under the included reference. And if you click on it, actually, they kind of like get reordered and shown here. We had excluded 3,300 references. And because we were stopping early, we were stopping the screening early, because actually one of the graphs I've shown in the earlier slides actually was from this very specific project. We've actually not screened 809 references as well. So basically here you've got like your whole references, and so you can filter them down like that. But then also what you have here is a search interface. So this is how basically you can apply tags to your Swift Review project. So here, for example, you can see I've applied a search. I've searched in title and abstract, and I've searched for 3 terms: severity, age, and old with a wildcard. And then I've used the proximity operator. So basically what I'm telling Swift Review here is I want any documents where these 3 words, including that world with the wildcard, is in like a 10-word proximity. So, and when I execute it, you can see here on the top right in the document preview, how it matched severity here, and then older age, thanks to the fact that we actually used the wildcard. Old and age, exactly. So basically these are the tagging categories, and these are the ones that we actually this is what we applied to like categorize our references. But you can like you can just do other searches as well. Like for example, I've got some copied here. Like for example, I can say heart and virus. And then it gives you like these ones, or you can actually, if you're an information specialist, like for example, the hypertension search that I've shown earlier, you can just create quite like sort of sophisticated searches as well. And if you import the references from PubMed, then you can also search mesh terms. You can use like the not operator as well. But if you go to the tag browser, for our evidence map, because we wanted to do protective and risk factors. For example, we had like we developed like the environmental risk factor category. And under this category, we just sort of had like different subcategories. So we had like social factors, weather, infrastructure, occupation. And you can see actually down here, if we like filter these references down, that this is the first 1.5 months of pandemic research, and almost everything was from China at this stage. Yeah, for example, if we go to like the weather references, you can see that there are only 22 in this data set right now. Then what if I want to, like, you know, for the evidence map, visualizations are very important, because like evidence maps really live from, like, you know, their visual outputs. And so after basically tagging everything for weather automatically and then manually going through and maybe deleting any tags that weren't relevant, you can compute a fingerprint analysis, which is right now, wait, this is, oh, I've got it. Can you see the thing? For some reason it now isn't showing.
I can see a box and it looks like it's got like a word cloud, but it's not. I can't see the whole image.
Yes, I think. Wait, give me a second. For some reason, maybe it's never done this before, but maybe that's because I'm like, yeah, here we go. Sorry, it just took a while to adjust itself. Can you see the normal image now?
Yes.
Yeah, sorry, it just took I think maybe there's a little bit of time lag with Zoom, or I don't know, but this is basically the word cloud. It's now giving me related to, you know, all the references that we've tagged for weather, because you probably remember that at the beginning of the pandemic, they were saying, especially they were doing all these modeling studies, and they were saying, especially in the evidence that came from China, is that transmission was reduced with higher temperatures. So that's why, because this is an evidence that we sort of picked up, I guess, these kind of like signals from these kind of like studies, and now this is what we're visualizing here in our references tagged with, you know, the sort of systematic search for weather within the data set. So you can see that some of these words here, they are, I mean, certainly weather related, but you can also see that some of them, they have like an A or a T. So A means temperature in abstracts, and T means temperature in titles. And in this specific data set, we have not imported references from PubMed, but if we had imported them from like PubMed files, you would also, in the word cloud, find the mesh terms as well. So if there was like, say, like mesh terms for like, probably not for a weather related category, but really for any health category appearing, then they would be like, they would be in the word cloud, but with an M. And then just a few, because I think word clouds are always a bit subjective. I mean, some people like them, some people don't. For the people who don't like them, they can also go into the fingerprint analysis, at which like you get the underlying data for the word cloud in a tabular format. So we can say, for example, temperature in title, word count was 11, and then the inverse document frequency, which is basically a way to categorize the importance of a term given how many times it appears to, like, you know, the score, the document frequency and the score basically together in a way tell you the importance of a specific term, because it's like a analysis of how often does my term appear versus in how many documents does it appear. And, you know, if something appears in almost every single document, then that term is not really too important. But if it appears, like, say, in a certain selection of documents, but it seems to be highly relevant there, then it gets basically a good score. So yeah, so there you have these fingerprint analyses and the word clouds. And, you know, like now I computed the word cloud just based on like this subset of categories, but I could also like compute it based on any category or any topic. So these are the ones, these behavioral, physiological, demographic, and environmental, as we actually created them for this project. But then there are other categories that are kind of like inbuilt. So whenever you like import your references into Swift Review, you do actually get these categories. So for example, TOX21 chemicals, you actually have like a overview of you know, relevant like chemicals. And this is probably again like more relevant to like the toxicology domain, but also it is quite good to identify like pharmaceutical substances and drugs. So for example, and there is also some like basic like synonym resolution in there. So for example, the code vitamin C and L-ascorbic acid, for example, would automatically get applied to your project, and then you could like filter everything, for example, that contained vitamin C, and it would actually like show this. So like any of these tags like lopinavir, ritonavir, I think they were like the first drugs that were being used. So you can see just like automatically Swift Review would have actually told us that these were the most commonly found drugs within our data set, even like without any screening. And then there are topic models as well. So these are like health specific topic models. And then again, for anyone like interested in actually doing these topic model analyses, you know, this is a very exploratory kind of way, I think, of looking at your analysis. But you have, for example, topics that are found like group significance, higher, lower proportion, like this kind of topics. But then also like a sort of China outbreak kind of cluster, and sort of like a patient and disease, age, risk sort of reference categorized as well. But then this is always, of course, like highly project specific. So any kind of data you put in there would just create, you know, its own like topic models. And I was thinking like I would really like to put part of our Twitter data set in there just to see what topics active Swift Review, actually comes up with as well. But that's probably like a, you know, discussion for another day. Yeah, so I guess in terms of like what's on the horizon for this, that like Swift Review right now, I mean, as I say, like everybody can use it and it's available, but it's a desktop application. But right now people actually prefer web applications. So we've actually already created a newer version of Swift Review that is completely web-based, but that has the same features, but together with like Fiddle, that's actually in like beta and user testing right now. But the thing is, like, even now, if you like want to do like a project and share it, it's quite nice because you can basically, just like as I've shown you now, like you can like share your project and make all the different taggings and categories and like exploratory way like available for anyone. But it would just be much nicer if it were a web application, and that's sort of like, you know, on the way. And then together with that, like having it on the web basically allows to not only do these analyses on title and abstract, but to also do them on segmentized full text. So to be able to like, you know, run any of your tagging strategies on the full text method section or the, you know, like the full text results section. That's something like hoping to sort of release that within the year. Yeah, so that is this so far. And then I think just I have a couple of more slides really here, but that was just about, you know, the project that I've just shown you, this sort of COVID evidence map with the risk factors. We could maybe quickly go through that if you liked, or we could do it really quickly. Maybe I can do it within like 10 minutes, and then we should have like 10 more minutes. for questions.
Sorry, Lena, can I just, it's
Yeah.
Anna, hiya.
Yeah.
Were you involved in the creation of that system?
I was I started working for SciOM after Swift Review and Active Screener were released. So I
Right.
wasn't actively involved in the creation. I was involved in some of the updates, like the inter-rater reliability and some of the newer features.
The reason I'm asking is in a past life, I did database development, nothing to do with research. It was a business that I worked for, and it's genius what you've created. It's absolute genius. I've just thought I needed to say that because I've created similar systems and worked with people creating similar systems. Not the IT side of it, but speaking to them about speaking to users about what they want and what they need, and then trying to create the system that provides that for them. And I mean, it's complicated. I can see that it's complex, and if you're not used to using this type of thing, it might take some getting used to. But from me looking at it, I can almost hear the smile in your voice that I used to get when I used to get excited about a system that we were putting together, which is why I wondered if you'd been involved in setting it up. But sorry, that's a totally off topic, but I just wanted to say that.
Yeah, luckily I'm a data scientist in that sense and not a software developer. So I've sort of seen that, the newer web version of the system was built sort of from ground up. So I've seen that it is really, really hard, and all the planning ahead that you have to do to get all your features right, and to constantly speak with the users is so important, because otherwise gonna end up with a system that's super complex and really hard to use. It maybe even has too many features, but it's not usable as well. So it's really hard to strike that balance.
No, I can, I think what you've done here is pretty impressive. You seem to have thought of everything and beyond. So anyway, I'll let you get on.
Yeah, so basically what I mentioned before, this rapid evidence mapping process that we've done to actually create the COVID map that I've just showed to you, basically was motivated by the fact that, of course, traditional systematic reviews are way too expensive and take way too long. But that's generally, I think, the thing that many people complain about, and that's really the core of why we want to automate evidence-based synthesis research. And then sort of after traditional systematic reviews, in the recent years, evidence mapping in itself has come up. And that's just because it is so much nicer to actually be able to share your research results and to make it, actually also appealing to people to look at them and to motivate them to scope your research, to find the evidence gaps as well, and to be able to share projects, and communicate research in an interesting way, really. So that's why sort of SciOM, that was pretty much around the time when I joined SciOM, started looking, at review methods, review protocols, types, but also at different parts of automation to really specifically speed up evidence mapping processes and to reduce the costs for universities, but also businesses and industry. They also want systematic reviews and evidence maps, so, and they really want this process maybe streamlined even more than we academics do. So the basically end result of that was a rapid evidence map, where we tried to find really the most resource efficient methods and focusing on visual representation and easy sharing and dissemination of results. So I guess, every systematic review methodology, or every methodology related to evidence synthesis, really has its pros and cons. So systematic reviews, they're really, they're not very time efficient, but they're very methodologically rigorous. And then we have rapid reviews that they look at the same body of evidence, but they're trying to simplify the methods to make the process quicker. And then we have scoping reviews that they're not looking at the same type of evidence, they're looking at a much broader type of evidence. But they're also, because the evidence base is now so broad, they also need to somehow simplify the methods. And then there's sort of rapid evidence mapping, where we've tried to like take almost the best of everything. Like we try to make it methodologically as sound as possible, but also integrating as much automation as possible, much more automation than maybe your normal systematic reviewer would be comfortable with. But certainly something that maybe some of you would be comfortable with, since you're like, you know, working in the areas of horizon scanning and health technology assessments. And then of course, thanks to the pandemic, living evidence synthesis and living reviews really highlighted some of the massive problems that we have with systematic reviews, sort of in terms of like timeliness. And, you know, like if your evidence is urgent, you really want your overviews of your evidence, you want them to be accessible. And I think those living review protocol mostly was written with automation in mind, even to like help you, you know, do that. So we did like a little bit of proof of concept research on comparing, like, you know, the rapid evidence map to a normal evidence map. So this is something my colleagues at SAM did shortly before I joined them. They took a published evidence map on low calorie sweeteners, where, like, you know, reviewers had actually gone through the whole step of title abstract screening, full text screening, and then they compared that with the and manual tagging and manual reference categorization. And then essentially what my colleagues at SciOM did is they just did a rapid evidence map on exactly the same evidence base with exactly the same literature. And then they compared their conclusions, and they found that actually they essentially had the same conclusions compared to the traditional evidence map, but they saved 80% of the time. And just shortly after that, we actually did the rapid evidence map on COVID-19 risk factors. So I think in general, the first step really for us was we published a protocol. And then our aim was to identify risk and protective factors for COVID. And we were looking at all COVID-19 literature published until April 2020. And so the search, normally for the rapid evidence map, we would go and actually search PubMed and Scopus and Embase and really like any kind of literature source that, you know, you would want to be searched. But because COVID was so new at the time, there was this COVID-19 open research data set that was actually given by a semantic scholar and the Allen Institute of AI. And they had already integrated PubMed and preprints and Scopus and Embase, and they had just basically at that time that was the largest collection of COVID research, and we just imported all of it. So we imported the whole of the COVID research literature until April 2020. And then in terms of eligibility criteria, what we did is we've included original sources of new data in English, looking at human populations, but we were excluding any animal or in vitro studies. And in order to be included, the papers needed to report at least one risk and one protective factor. But again, like no directionality of effect or anything, just risk and protective factors for COVID. And then we screened titles and abstracts in active screener. So basically what we did is in active screener, the first thing you can do is you can dual screen references. So we did that as a screening pilot. For the first 100 references, all 3 of us reviewers that were screening, we screened the same 100 references, and then we resolved our conflicts. And then when we realized, okay, now we're calibrated, we went on to do single screening. So no duplication of effort. And we screened until active screener told us, you know, we have found 99% of our studies, which I think essentially in the end, like we ended up not screening 800 studies. And then we developed risk and protective factor categories. So those basically, we use terminologies from the Dahlgren and Whitehead model for the determinants of health, and some, terminologies from the WHO, and came up with these 4 categories. One is behavioral, like smoking, or, for example, smoking, and physiological, for example, like blood pressure. Demographic was like age, gender, and then environmental would be like something like, for example, the weather category that I showed you before. And in some cases, such as age, actually can be both risk and protective factors, but we've only, like tagged and included for the factor itself, but there was not really any, like, we didn't look at statistical significance or direction of effect or anything. And for every risk factor category, for example, here for hypertension, this down here was the search that was then developed, and to all the relevant references in Swift review, there were like about 219 references. We would have then like applied the search to tag the references, and then to manually basically to first automatically tag them, and then manually check later. And yeah, so basically for all our 4 groups of evidence, we and all our tagging factors, we basically just tagged all of them, and then manually verified them. And in the end, sort of, this is like the study flow from all records from the core data set. Sort of, we included 217 studies. We didn't screen 809 of them, and then in the end ended up with the evidence map. So it's kind of published here, and the Swift review file that you can actually download and look at. That's the one that I've just shown before, is right here. And then we've done like some plots. These show like the studies and the amount of people within the study, so the study size that were tagged in the 4 main categories, and then also the number of studies. Like, for example, here on the bottom right, like 98 studies were like tagged by like age, 31 by gender, and yeah, in general these are the results. But anyway, like as I said, like there's no directionality or risk of bias assessment involved here. These are literally just tagging results. But we found like, history of smoking, malnutrition, and cancer treatment was sort of mentioned for the behavioral risk factors. Physiological, the biggest group really was comorbidities, which is something I think now it's easy to verify that this is actually true, because we've gone through 2 years of pandemic. So we can look now back at this evidence map and we can say, was it actually sort of valid ideas that we've sort of picked up? Was it like valid sort of evidence signals that we picked up within this data set? And it basically said physiological, the patients with comorbidities were the ones at higher risk, and then body mass index, of course, and then blood type was something that was like also I think discussed in the media quite a lot at the beginning. And then environmental factors, you can see like lockdown measures, they were just beginning to show like a little bit of evidence around like what happened when they locked down in China, and healthcare resource availability, and then protective factor, we found things like young age, and there was something about this BCG vaccination that we found. But in general, yeah, I mean, this is evidence mapping, right? So you can't really make any recommendations on healthcare, for that, and we didn't do any quality or risk of bias appraisal, etc. And we could have done it, but at that stage we actually just did this project within like 5 weeks, pretty much. Yeah, the project itself only took us 5 weeks to do the whole start to finish, but then it took another 5 months or so alone to publish it, like submitting and getting it published. So I think it was published eventually in November 2020. And then of course, like sort of on the future directions of this, like these rapid evidence maps. So it would be nice to actually start maybe a couple of projects or tests where, you know, we can make them living and continuously update them, continuously like screen on like specific projects. And this is just like a last little overview, because mostly like the science software, we work together with the US agencies, and, you know, like HAWK, for example, Health Assessment Workspace Collaborative. So these are kind of like the systems that this already integrates with, but like we're always like really happy to like integration or like testing in any kind of other applications, like you know, like any work that Nerio is doing obviously is really, really quite interesting, like any horizon scanning, and like would be really interesting in a way, like, you know, to also test these tools, you know, in this kind of like evidence-based research. Yeah, I mean, I think I've pretty much already had this slide, so that's it. Oh my God, we don't have much time for questions now, but I'm just gonna get back to you and see if maybe you guys have any questions.
Thanks, Lena. That was absolutely brilliant, and so interesting. So there is a question in the chat that said, can you get weights to quantify the contribution of the different factors in the REM?
Wait, sorry, I couldn't catch it. Could I do what? Sorry.
Can you get weights to quantify the contribution of the different factors in the REM?
So the what we've done is, maybe I'll just quickly reshare. So the closest I think we would have done, we would have come to that is when we, oh wait, let me quickly skip back here. Can you the one way how we've weighed it in a way is we've basically manually annotated the number of participants in each of our included studies to see, you know, like for example, in all the behavior, like you can see, for example, the behavioral risk factor.
Lena, sorry, we can't actually see what you're talking about. All it says is Lena Schmidt is started screen sharing. We're not actually seeing the.
Oh no.
What's on your screen?
Oh, I've actually paused it. Okay, now I'm gonna stop the share, and now I'm gonna share it again.
Thank you.
Can you see it now?
Yeah, thank you.
So basically, that's one thing that we did, is we've tried to, like, you know, annotate the number of included study participants in each study, and then to visualize this here. So for example, our behavioral risk factors studies would have had, like, I don't know, 300 to 500 people. But the thing is, what I have to say for this, like the studies here, it was very heterogeneous. So behavioral risk factors, those would be actual studies with like patients in hospitals, whereas the demographic risk factors would be like, you know, they weren't like RCTs in the common sense. They would be like maybe large cohorts of people, like say, for example, all people living in province X in Beijing or something like that, that were affected by a lockdown or something like that. So this is a way how to weigh it. And then otherwise, I think the weighing or like the importance of the studies within the evidence map will probably be also highly project specific. Yeah. I hope that that's what was intended with the question.
Okay, or would you like to clarify that? Anyone? No, right, we've got a thanks from that. Obviously, we've come to the end of our allotted time. If anybody else has any questions and Lena has time, then we can hang on for a few more minutes. Or Lena, would you be happy for people to contact you?
Oh, we can discuss for another couple of minutes. That's absolutely fine by me. Or if you have a question and you want to like drop off, like you're welcome to message me anyway. But yeah, anyone who has a question, we can also share it now. That's fine.
I mean, I was wondering about, Fiona's asked if we can have the slides.
Yeah, I can
Yeah.
share those.
We'll share them around.
They're not for like, I think, much wider sharing, but like if you want them, you know, like they're not absolutely confidential, but yeah, just for you guys, yeah, definitely.
Thanks, Lena. I was wondering, you did kind of answer this, but I wondered, you know, about how this could be applied to other sources of information, like obviously the Twitter work and the horizon scanning and grey literature and things like that. Do you think it would be useful for, you know, all kinds of information?
I think in general, we'd probably need to test it, of course, like because say like scrape text from a website or, you know, a tweet or something like that is not essentially like the scientific information that these tools were set up to use. But yeah, I've been thinking myself, like if we could analyze tweets or social media data, that would be cool. And then, you know, we've been also at Nereo, like we've started developing like a classifier tool as well, like specialized on the, you know, like on the data from the scans. So I think in general, like these methods are very broadly applicable, but if it comes to like, you know, very specific like horizon scanning use cases, then it might actually also be interesting to have like a chat with my colleagues at SciAm to see, you know, if there are some like very specific data pipelines or like a couple of little changes you could do to the software to actually make it more interoperable, you know, with the horizon scanning use case.
Yeah.
But I mean, certainly it could be tried to apply, like, and that would be interesting to see, and then it could always be improved.
Yeah, because I think quite often with things like the horizon scanning and things like that, you know, we were chatting this morning about a project and it's like it's difficult to deduplicate and it's difficult to, you know, manage the information, and there can be such a, you know, huge amounts of data coming in. It could be really useful.
So basically one of my first tasks, and I spent over half a year of that at SciAm doing that, is actually writing a new deduplication algorithm for them.
Okay.
So I'm very well aware of like how complicated it is and how careful you have to be. But like, yeah, my deduplication algorithm, like hopefully will be like in the web version of the software once that gets released. But yeah, of course, like, you know, the deduplication alone, like it has to be very precise, right? You don't really want to lose any relevant references. So we've really tried to make a user interface actually that shows you the duplicate groups that the software was least happy with, for example, and then you can like manually select those duplicate classes. You can manually check them, and then the rest you can just run it automatically, for example. So I know that it's a very, very hard task, but we're working quite hard to solve it.
Brilliant. Oh, that's good to know, because I think that would be really, really helpful. Has anybody else got any more questions they'd like to ask Lena at this time? I think that's all for now. I'd like to say a massive thank you to Lena, because I found that absolutely fascinating. Yeah, if Lena can share the slides with us, and then we'll share them with a disclaimer to not share them outside the group, that would be brilliant.
Yes.
And I'm sure a few people might be in touch with you. I know I will be. And I'm sure a few other people will be in touch to pick your brains about this, because it's really, really interesting. So
yeah. If any of you want to use any of the tools, like for Active Screener, for example, you need to actually sign up. But if you want to use it just to test it in a research project, I've talked to my colleagues at SciAm, so we can just give you like a test license if you want for like any project. If you wanted to try it. Yeah.
I was just going to ask, does Newcastle have access to Active Screener?
No, I think because there would be like an institutional license required, but as I said, like you can just try it, and I've talked with my colleagues, so they're absolutely fine with you guys trying it. Just if you wanna, just for free, it's fine. Right. Doesn't matter.
Thank you, that's great.
But just message me, just drop me an email, even anyone who's not here in the group right now, like if you think like they'd like to try it, just drop me an email and I'll get you registered.
Brilliant. Well, thank you very much, Lena. We'll call that a day then. So we have one more session of the group, I think, this year before we break for the summer. So that is in the end of June. And the subject for that day is, sorry, I always mean to do this in advance and always forget. So Nicole O'Connor, who is one of our colleagues in the evidence synthesis group, is going to talk about core outcome set development. So what we will do is we'll send a link around to register for that as usual, and we hope to see you all then. And then after that, we'll be breaking for the summer and we'll be back in September with potentially, hopefully, a slightly different format, but we will let you know about that when we're more certain what it's going to be. So thanks everyone for coming today. We hope you find it useful. Thanks to Lena, and hopefully we'll see you again next time. Thanks everyone.
Thanks very much. That was great.
Thank you. Bye.
Thanks,
Bye
bye.
everyone.